Okay, so what we're going to do today is draw the Lewis dot structure of SO3, sulfur trioxide. And we have those 6 steps that we use in order to draw this molecule. So let's go through those 6 steps. The first step is to count the total number of valence electrons. And we're going to get that from the periodic table. So I look at the first atom, and the first atom is sulfur. And I look at what column sulfur is in, and from the periodic table, every sulfur atom has 6 valence electrons. And according to our formula, there's only 1 sulfur. So that means sulfur is going to bring 6 electrons that we can use to bond. Oxygen, each oxygen atom has 6 electrons itself, but in this molecule there's 3 oxygen atoms. So 3 times its 6 is 18 valence electrons. And then if I were to add those up, that means that this molecule, the most I can ever use is 24 valence electrons, no more and no less. So now I'm going to draw the molecule, and I'm going to pick which element's going to be in the middle. So it could be the sulfur or the oxygen. How do you know which one? Well, it's usually the one that comes first. There are some rules, like it's never hydrogen, it's rarely any of the halogens. If there's carbon in the molecule, it's probably carbon. In this case, it's going to be sulfur. So we're going to draw an S in the middle to represent sulfur, and then we're going to draw a line, which is going to represent a bond to the 3 oxygen atoms, right? Because the formula tells us it's SO3. So those bonds, those lines that I just drew, are 2 electrons that are shared. So since I drew 3 lines and each line is 2 electrons, I just used 6 electrons to make bonds. So in that line where it says minus electrons used to make bonds, I'm going to put a 6. And what does that give me left? That gives me 18 electrons that I have left. 18 electrons that I have left to do step number 3, which is make the octets of the non-central atoms. So what do I mean by an octet? I mean that each atom needs 8 electrons around it. Right now, if I look at the outside atoms, they're all oxygen. They have 1 bond. 1 bond means 2 electrons. I need 8 electrons, so therefore I'm going to need to put 6 electrons around it. And so what do? I put little circles, dots, and these are standing for electrons. And I put 6 around each of the oxygen atoms. Okay, and those 6 electrons now filled the octet of the outside oxygen atoms, right? I need 8. They had 2 from the bond, and now since I put 6 dots around it, dots are electrons, I have used 18 electrons to complete the octet of the outside atoms. So how many electrons do I have left over? I do that subtraction, and that tells me 0. Now, I'm only done with drawing a molecule if 2 things have happened, right? And I need to look at these. If all the electrons are used and every atom has a full octet. Okay, so I've done this one. I've used up all my electrons, but I look at my molecule and I ask, does every atom have a full octet? And the oxygens do, but sulfur does not. Sulfur needs 8, but it has 3 bonds. Each bond is 2 electrons, so it has 6. Sulfur needs 2 more electrons. I can't just put dots around it like I did for the oxygen because I have run out of electrons. And so this is when we use a double bond. A double bond doesn't just occur. I need to reassign electrons. So if I look at the electrons down here, these 2, I have put these electrons around. Is that they only orbit the oxygen. And I'm going to reassign those 2. So I'm going to erase those 2 electrons, and instead of them solely orbiting the oxygen, I'm going to put another bond in there. Right? 2 electrons needed for a bond. So what I've said is now they're going to be shared, right? Covalent bonding is all about sharing. They're They're going to be shared between sulfur and oxygen. And now I have filled both of the conditions for being done. I used up all my electrons and every atom has a full octet, because if I look at sulfur now, right, look at sulfur in the middle, sulfur has how many bonds? A single bond, and a double bond. Each bond is 2 electrons. A double bond is 4 electrons. So that sulfur now has 8 electrons, and yep, every atom has a full octet. So what I've just drawn is the Lewis dot structure of sulfur trioxide, SO3. Every atom has a full octet, and I've used up all my valence electrons. Again, and this is really important, I only can make a double bond, right? See how I made a double bond here? I can only make a double bond if all electrons are used up. That's the mistake that I see most students make.